Welcome to the Genius Factory. Enjoy the video.
You start by verifying hardware and drivers. Check your NVIDIA GPU model and ensure the driver is compatible with the CUDA version you plan to install. Next, install the CUDA toolkit and the matching cuDNN and export path and LD library path so the system finds them. Then create a Python virtual environment, activate it, and install PyTorch with the CUDA-enabled wheel. Finally, pip install Ultralytics version 8. So Yolov8 can use the GPU. This gets you ready to run training. Once the environment is ready, you verify GPU access in Python, check torch. CUDA is available and device count. Then prepare data. YAML with class names and paths and adjust batch size to fit GPU memory. Smaller models allow larger batches. Make sure to enable mixed precision, float 16 for speed and lower memory use. Finally, run the Yolov8 train command with your model, data file, epochs, and image size. Monitor GPU utilization and memory during the first epoch to confirm the GPU is active. To finish setup and optimize, explicitly select the GPU with device 0 or by setting CUDA visible devices and enable automatic mixed precision to boost throughput. Then tune batch size, input resolution, optimizer, and learning rate schedule for best results. You often get big gains from larger batch with tuned LR. If something goes wrong, here's the key troubleshooting tip. When you hit out-of-memory errors, reduce batch size or image size, enable FP16, or use gradient accumulation so you keep effective batch but lower memory usage.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.